Hi folks, if you're just getting started on AWS and you're trying to decide on a strategy for deploying your first web application, well, you've come to the right place. My name is Derek Bingham, a developer advocate at AWS, and over the next 30 minutes I'll show you the options I would choose when deploying web apps on AWS and why I would choose them. So in this session I'll cover what I think are the 3 best choices that you have when deploying your apps on AWS. First off, I'll examine deploying static website content and front-end apps and the best option that you can choose for those. Then, I'll cover 2 popular approaches for cases where you have back-end code you'd also like to manage in your app. The first of these is for cases where you want full control over your environment in an easy-to-get-started fashion. So we'll talk about running your own virtual private server. The second of these, we'll look at another service that helps when you want a more managed experience. This is where AWS will take care of OS patching, deployment uptime, scalability of the application, and database services that your app uses. So let's start by talking about hosting static websites and front-end web apps. If you're building a single-page web app, then when it comes to delivering your front end to users, you just need a way to deploy and host a set of static HTML, CSS, or JavaScript files. Or maybe you're hosting a static website generator like Hugo and Jekyll. For these cases, I would certainly recommend the Aws Amplify Console service. The Aws Amplify Console service is a static web hosting service that accelerates your application release cycle by providing a simple CI/CD workflow for building and deploying static web applications. Simply connect your application's code repository in the console, and changes to your front end and back end are deployed in a single workflow on every code commit and subsequent push to the code repository and monitoring. The Aws Amplify Console, you can deploy single-page apps, or SPAs, built with frameworks like React, Angular, and Vue, as well as static sites generated with frameworks like Gatsby, Hugo, and Jekyll. You can also host simple static websites without connecting to a Git provider just by performing a drag-and-drop deploy, selecting a folder from your desktop, or by referencing an Amazon S3 bucket or external URL. The Amplify Console also works seamlessly alongside other AWS tooling, which makes it really easy to provision, configure, and connect back-end resources like APIs and databases to your serverless web apps. Let's look at a few Amplify Console features. One of the best features of the Amplify Console, in my opinion, is how it makes it really easy and painless to set up a continuous integration and continuous delivery pipeline. As I have already mentioned, to get started, you simply connect the Amplify Console to your Git repository, which could be GitHub, Bitbucket, GitLab, or Amazon Code Commit. Then the Amplify Console will introspect any code that repo and suggest a build script, or you can use your own. It can also automatically watch for any changes to whichever branches you elect to monitor. Whenever a change is detected, it will automatically provision a new environment for your app, build your app, and run any automated tests you've included in your repository. Deploy your updated app version if all of your tests pass, and then verify the deployment has succeeded. Yep, all of that. Each new deployment is also executed in a completely atomic fashion, ensuring that everything needed to host your new web app version was deployed successfully, and it begins to deliver this content to your users. It also performs instant cache invalidation as part of your deployments, ensuring that the CDN is not serving old cached content that was changed by your latest deploy. And then finally, if you follow a development workflow when you create feature branches for your work, Amplify Console can also help you here. You can manually connect many different branches as you like, and the Amplify Console will monitor and deploy each of those branches independently. You can also configure a pattern-based feature deployment setup so that the system will automatically deploy new branches that match your desired pattern. So perhaps branch prefixes with beta or release are great examples of this. AWS Amplify Console will also set you up with a global scalable hosting service. Your app is distributed and hosted by AWS's huge content delivery network with over 200 points of presence all over the globe. This means that when the users load your website or app, your browser will automatically fetch the content from the server that is geographically close to them, resulting in faster load times and a better user experience. By default, your app is served via an automatically generated domain, but The Amplify console also makes it very easy to set up hosting from your own custom domain, and it will even help you generate and use a free HTTPS certificate for secure content delivery. While we are on this topic of security, you also have the option of protecting your app with a simple username and password authentication flow, which is great if you are deploying multiple feature branches of your application and you want to protect some of those deployments from unauthenticated users, or you only want grant access to UAT or beta test group, which is as an example. Hopefully this all sounds pretty cool and you want to see how to get started with the Amplify console. Well, let's see. You just need to connect your code repository and review the auto-detected build settings and make any necessary changes. Then your first app version gets deployed. Let's take a look at a short demo to see what this looks like in action. We'll start from the home page of the Aws Management Console. From here I'll search for Amplify, or is it just click on it and a recently viewed service list. So these are all the apps I have deployed in Amplify Console. To create a new one, I simply select Host Web App. Here I just need to connect to my Git repository. In this case, I will choose GitHub. It will already authorize in the Amplify console with my GitHub repo. And once it's done, I will select the branch to monitor, and then I'll select main, and then I'll click any monitor repo I can do if I want to. But for this one, I'm keeping it simple. Here are the build settings that's been introspected. You'll see it's all done that for me. I can also have more advanced settings, like a build image, add some environment variables if I want, and dive a little bit deeper and get more complex. For this demo, I'm keeping it really simple. So when I click next, this builds and deploys everything in a pipeline. So I've got steps in my pipeline: provision, build, deploy, and verify. If I want to go see what happens in each of those stages, I can actually click into them and it will show me what is going on. So here I am in the provision stage, and looking down the build logs for provision, you can see what's going on. And then if I also select the build stage, I can also see that currently it's cloning the repository. And so any problems that I've got during my pipeline, I can introspect and look at them there. So let's just speed this up a little bit so we get our application deployed. There we are. So we build, deploy, and verify. Here is the application itself. So I have a URL as a service to my application. It's a simple compare application, so I'm comparing apples and pears and various types of fruit. But what if I wanted to change that application? Let's do that now. So the first thing I need to do is clone my source repository. So if you remember, Amplify Console is monitoring this source repository that I set up when I created my app inside the Amplify Console. So I'm cloning the repository locally so I can start developing on it. Once it's cloned, I need to then open it in my favorite code editor and find somewhere that I like to change. So for this app, I think I will change the header. So in the first page, from compare these great products to compare these awesome things, because that's more descriptive. So I'm just changing that now to awesome things. Save that file, and then back into my terminal and git add. Do a commit message that's very descriptive, and then push that change up to my Git repository that Amplify Console is monitoring. So if I switch back to Amplify Console, click into my application, you'll see that's already running. So it's already picked up the change, and it's done the provisioning phase. It's now on the build phase. So if I speed this up again, you will see that once I hit verify, go back into my application, do a refresh, you can now see that that change has been nicely verified and it's a part of my application. So that works really well. So that was the Amplify Console, a great place to start hosting your static web content. But what about cases where you want a full server to host your apps? You might have your own PHP, Ruby, or Node.js app, or you might want a way to easily stand up a new server with existing open source software like WordPress, Magento, Drupal, etc. For simple variants of these cases, the best place for you to start could be with your own virtual private server in the cloud. And the easiest way of getting started running your own virtual server in the cloud is with using Amazon Lightsail. Lightsail is an easy-to-use cloud platform that offers you everything needed to build an application or website, Plus, this service is delivered via a cost-effective monthly plan. Whether you're new to the cloud or looking to get to the cloud quickly with AWS infrastructure you can trust, we've got you covered with Lightsail. It's ideal for simpler workloads, quick deployments, and getting started on AWS. It's designed to help you start small and then scale as you grow. Getting started with Lightsail is really easy. It comes with its own separate web console that is a lot simpler than the rest of the AWS console. It's very helpful because it was built to show you all of your Lightsail resources in one place with meaningful defaults for launching new servers. Every Lightsail plan includes a server with a static IP address, secure networking, built-in DNS management, one-click SSH terminal access for Linux or Unix systems, and then one-click remote desktop access for Windows servers. It also has highly available SSD storage, server monitoring, and much more. Lightsail also comes with a very simple billing model, giving you low, predictable pricing. When you create a Lightsail virtual server, it's easy to see how much you're going to pay each month. Managing your resources in Lightsail is not only easy, thanks to its simple web console, but it's also flexible too. Every action you can do in the web console can also be done by making API calls to the Lightsail service. As well as offering virtual servers, Lightsail also lets you create fully managed databases and load balancers with fixed pricing. And if you get to the point where you want to bring your resources out into a wider AWS ecosystem, well, Lightsail makes it easy to snapshot and export your virtual machines onto AWS Elastic Cloud Compute, or EC2, which allows you to provision virtual machines with more fine-grained control over compute, memory, and storage capabilities. Finally, if your apps live in a container ecosystem, Lightsail also provides the ability to run your containers on a managed Lightsail instance. So why choose Lightsail? What are the benefits? If you're already a bit familiar with AWS, then you may know about Amazon EC2, which also allows you to run virtual machines on the cloud. So the question you might be asking is, when should I use Lightsail? When it is more appropriate than EC2? Well, Lightsail is best suited for small-scale generic apps, websites, or web applications where you might only need one or just a handful of servers to deliver your app. It's also a great choice if you're looking for a low-cost virtual server with a generous amount of included outbound network data transfer included in the pricing. EC2 is a better choice if you need to provision a large, complex environment with dozens of virtual machines, or for any cases where the workloads with advanced networking needs are ones that require specifically optimized virtual machines, things like big data and analytics or high performance scientific computing. For a lot of use cases, the Lightsail simplicity and affordability are the right choice. Lightsail makes it easy to deploy a web application with just a few clicks with pre-configured development stacks like LAMP, Nginx, Mean, and Node.js. We make it easier to get a server created to host your web application quickly. You can also use Lightsail for quickly create a website that shines. Create and customize a blog, e-commerce, or personal website with Lightsail's pre-configured applications like WordPress, Magento, Flask, Plesk, and Joomla. Or easily run source and commercial software for your business. Lightsail helps you quickly launch your line of business software like file sharing and storage backups, financial and accounting software, and much more. One great feature about Lightsail that I want to stress is how easy it makes to get popular operating systems and applications installed on your own virtual private server. Lightsail offers a large number of pre-configured one-click-to-launch application or developer stacks, including WordPress, Plesk, LAMP, Node, and more, and operating systems including Amazon Linux, Windows Server, Ubuntu, CentOS, and more. For example, if you want to get your private WordPress server or LAMP stack up and running on AWS, I can't think of a faster way than Lightsail. And speaking of LAMP stacks, the combination of Linux, Apache, MySQL, and PHP, I want to show you a quick demo of just how quick and easy it is to get a simple LAMP stack and application deployed on Lightsail. I'll start here with the Amazon Lightsail web console, where I'm already logged in. You can see that I'm looking at the instances section of the console, and there's a big Create Instance button. So let's click that to get started. Next, I can choose the AWS region where my virtual server instance will reside. We have regions all over the world, but in this case, I'll choose to place this server in Oregon in the United States. I also get to select the operating system that I want to run on. Since I want to deploy a LAMP stack, I'll choose the Unix platform and then select the LAMP PHP 7 blueprint. I could choose to go with a blueprint that only installs the OS, but by selecting LAMP blueprint, I get a server set up with PHP, Apache and MySQL, and I'll need to add as my code to the server. Next I'm going to paste in a simple launch script. Here to add my code, this is a set of commands that will only run once when the server is first initialized. And what it does, it starts off by deleting the default website. By default, the LAMP stack blueprint includes a default website managed by Apache. We're going to delete that so we can have our own website. Then we'll use Git to clone the application of our Git repo. Then there's a special connection values file that will set appropriate ownership on. Then we'll copy the password into a configuration file and create our MySQL database using that password to connect to MySQL running on the server. This is pretty standard installation script. It's the same sort of script you'd run on a virtual machine or physical server. That's just a set of steps we're going to install our application in the scripted fashion. Next I'll set my server backup times and where that is automatically, and I'll select the desired time of day that I want my backups to occur. Next I'll pick the instance size after I've set the time of day for my backups. Here I'll pick the $5 instance. The price of the instance governs the amount of CPU, RAM, disk space and data transfer that's included. Then I'll name my instance. Since I'm going to be doing a simple to-do application, I'll name my server to-do. Makes sense. Once I've done that, the last thing I want to do is optionally tag my instance. Here I'll add a tag that identifies this server as the one where I'm running my to-do application. Then I'll create click instance and wait just a moment for the server to get created with the application code running on it. So the server is now running. I can see its status there under this name. I can copy the public IP address of the server and then go to that IP address in my browser. So here's my simple to-do PHP app running. And if we look at these values that my app prints out, you can see that the front end host is showing the local IP address of the web server and the database host shows localhost, because in this case the database server and the app server are on the same machine. MySQL is running alongside Apache and the PHP engine here with the same Lightsail instance. And that's it. As you can see, it's really easy to get started and you can be up and running in this in a few minutes. Of course, sometimes we want more than a simple virtual private server. After all, when you have your own server, you have responsible for keeping the operating system and software services running on it, patched and up to date. What if you had a managed solution instead? For this case, we have AWS Elastic Beanstalk. It's a great way to keep your own applications to the cloud while having AWS manage much of the complexity for you. When you start out with a web app that you know you want to deploy, deploying it is just one thing. But you do have to do other things like design for high availability, dynamic scaling, safe version deployments. How do you keep your application runtime updated and the operating system patched? How do you monitor your application's health? Lots of questions. Of course, AWS provides lots of building blocks that allow you to build literally everything. This amount of choice is great, but many customers asked, is there just one service that I can learn to host my web applications? Well, luckily, the answer is yes. And that is AWS Elastic Beanstalk. Elastic Beanstalk is our easy to use service for deploying and scaling web applications and services developed with Java, .NET, PHP, Node, Python, Ruby, Go, and Docker on familiar services such as Apache, Nginx, Passenger, and IIS. You can simply upload your code, and Elastic Beanstalk automatically handles the deployment, including capacity provisioning, load balancing, auto-scaling, and application health monitoring. At the same time, you retain full control over the AWS resources powering your application and can access the underlying resources at any time. There is no additional charge for Elastic Beanstalk. You pay only for the AWS resources needed to store and run your applications. Elastic Beanstalk also provisions and operates the infrastructure and manages the application platform for you, so you don't have to spend time or develop the expertise to do this operations work yourself. It also keeps the underlying platform running your application up to date with the latest patches and updates. This means you get to focus on writing code rather than spending time managing and configuring servers, databases, load balancers, firewalls, and networks. We support many popular language runtimes, and you can even bring your own Docker containers if you've already done the work to containerize your app with its runtime dependencies. Besides the application runtime itself, Elastic Beanstalk manages quite a few other components as well. Starting with an EC2 host, Elastic Beanstalk manages the host operating system along with the application server and the language interpreter used to run your web app. It also takes care of the HTTP server itself on the host, and it puts your code in the right place so that everything works in harmony together to serve your application properly. If you were to set this all up yourself on a server you managed, you would have to make the initial decisions about all those components, and you'd be responsible for keeping them all up to date. Instead, Elastic Beanstalk provides a set of curated platforms and your application to run on, ensuring that these components are working seamlessly together. And Elastic Beanstalk can automatically update and patch these components during a periodic maintenance window that reduce your operational overhead. Getting started with Elastic Beanstalk is super easy. First, you create an application environment containing some information about the kind of application you want to deploy, and the configuration of load balancing databases and more. Then you pass your application to Elastic Beanstalk and it handles deploying it to your servers. And then finally, Elastic Beanstalk monitors your application environment and takes care of availability, scalability, and security. Let's see a short demo of all this in action. We'll deploy the same LAMP stack to-do app that we used before for the Lightsail demo, but this time on Elastic Beanstalk. So here I have back in the AWS Management Console. I could simply just search for the Elastic Beanstalk service up at the top, and that's what I'm doing now. Once I find it, click into it, we'll see the Elastic Beanstalk dashboard. I have no environment, so I'll create a new environment. I have two options, either a web or a worker environment. This is going to be a website, so I select web. I give my application a name. Again, this is our to-do app, so let's name it accordingly. Once I give it a name, I could give it some optional tags, but the next thing I need to do is I need to specify the platform version. So this is going to be a PHP app, so I select PHP. And then I have to decide where the code's coming from. So for this application, I've got code prepared. It's all already zipped on my local hard drive, so I'm just going to import that using the Choose File dialog. Once that's imported, I need now to configure some additional stuff. So these are all the additional things you can configure through Elastic Beanstalk. The stuff like networking, load balancing, how you manage updates. But for this one, I'm going to add a database. So here I'm selecting the database. Choose the type of database, which is MySQL. Choose its version. So I'm choosing a specific version that this app will run on. Next thing I need to do is I need to provide some admin credentials for this database. So I will put that in the username and password field. Once I'm finished with that, I just check all the other options. I'm single AZ, that sounds good. I hit save. So now, after I've hit save, it will start deploying Elastic Beanstalk with my PHP server and my MySQL database. I'll speed this up to save a bit of time, but you can see the progress of the deployment in Elastic Beanstalk through this console. So that's now all deployed. So this is my deployed app, to-do app in Elastic Beanstalk, and it gives me a URL that I can click into. Once I click into it, you can see that that app is successfully deployed. I'll now just create a test to do, so I can make sure that the database is all wired up, and there we are. Our to-do app is persisted, really easy to do, and that was all using Elastic Beanstalk. So in the last demo, you saw the initial deployment of our app. But what about for your subsequent deployments, once users are already using the app? Well, it turns out that there are a number of deployment strategies built into Elastic Beanstalk, and you can select the option that strikes the right balance for your specific needs. I won't read out all of them here, but for example, you can elect for an all-at-once deployment, which is very fast, but could result in a small amount of downtime for some users. Or you could elect for a much slower immutable deployment option that spins up new virtual machines of each deployment while taking more time to roll out. This approach has the advantages of making rollbacks quick and safe, since the machines hosting the previous version of your app were not touched at all during the deployment of the new version. And speaking of rollbacks, I should also take a moment to talk about Elastic Beanstalk's built-in health monitoring. When you're running a production website, it's important to know that your application is available and responding to requests. To assist with monitoring your application's responsiveness, Elastic Beanstalk provides features to monitor statistics about your application and create alerts that trigger when thresholds are exceeded. Here's a screenshot of an application environment health dashboard on Elastic Beanstalk. As you can see, you get a nice collection of metrics, graphs and alerts to set up for you all automatically. You also get automatic platform upgrades. As I mentioned, Elastic Beanstalk will provide you with regular platform updates that reflect patches to the OS and the runtime components. This feature is enabled by default, and all you need to do is specify a maintenance window when you're okay with having your instances patched and updated. I strongly recommend that you keep this Manage Updates feature enabled, as it's one of the ways you'll know that your systems are kept up to date without having to worry about it yourself. Lastly, I just want to point out quickly that we also have a really helpful Elastic Beanstalk command line tool. If you're like me and you often live in your terminal's command line, you should certainly check out the Elastic Beanstalk CLI. It has a number of built-in commands to help you do everything from creating and deploying the application environments, to monitoring the health of your applications, to scaling your apps, accessing your application logs, and more. So that concludes my short tour of these, our best services to help you run your web apps in the cloud. We looked at the Amplify Console, which makes it extremely easy to set up CI/CD for your static websites and front-end apps. And you learned about Lightsail's many built-in OS and application blueprints, and saw how quickly we could deploy a LAMP stack to a new virtual private server. And how you saw how you use Elastic Beanstalk to set up a monitored, auto-scaling, highly available, load-balanced LAMP app in only a few clicks. If you'd like to learn more about any of these services here, these are the best places to get started for each. Of course, every situation is different, and you might be wondering about other use cases that I didn't have time to discuss in this session. It shouldn't surprise you that there are other options available on AWS too, for serverless web apps to various options for data storage and containerized deployments. There are other many services that might be applicable to what you'd like to do for your web app. Here are just a few of my favorites that you might want to look at. For more information on these, check out the AWS website. Accelerate your cloud journey by checking out the featured courses to build your cloud skills on AWS, or visit the link below to explore over 550 free digital training courses. Thanks again for listening. We really appreciate your feedback so we can better understand the topics and services you would like to see more of. So please do take time, fill out the survey, and know what you think. So thanks folks, taking the time to let me share this session with you and staying to the end. Thanks so much. If you have any questions or comments that you'd like to share about today's session, please get in touch and you can find me on the socials. My name's Derek Bingham and I'll see you next time. Bye.